welcome to our presentation. My name is MacArthur. Myself, Alex, and Nick will be showcasing our presentation on the application of blockchain technology in wireless networks. We hope you find this presentation informative and enjoyable. So wireless networks have tremendously evolved over the past 2 decades. However, there's obviously still tons of room for improvement and many issues that demand solutions. Some of the challenges that are currently being faced in wireless networks include network congestion, which is when a node or link is carrying more data than it can handle and sometimes results in queuing delay or packet loss. Security, which includes data security, especially in regards to IoT devices, and of course lack of interoperability. There are many articles that elaborate how technologies such as artificial intelligence and machine learning can revolutionize wireless networks. However, blockchain tends to be overlooked as a potential solution, and this is despite studies showcasing how much of an asset it can be. Now, what exactly is blockchain technology? Blockchain is a system of recording information in a way that makes it difficult or impossible to change, hack, or cheat the system. It's essentially a digital ledger that stores transactional records in several databases and a network connected through peer-to-peer nodes. The technology continues to gain tons of popularity for being the backbone of asset classes such as Bitcoin and Ethereum, also called cryptocurrency, and for its potential to revolutionize industries such as healthcare. How does blockchain work? As I said before, a blockchain is a specific type of database. It differs from a typical database in the way it stores information. Blockchains store data in blocks that are then chained together. As new data comes in, it is entered into a fresh block. Once the block is filled with data, it is chained onto the previous block, which makes the data chained together in chronological order. Basically, blocks have certain storage capacities and when filled, are chained onto the previously filled block, forming a chain of data. This is why it's known as the blockchain. Next is the hash. A hash is a function that converts an input of letters and numbers into an encrypted output of a fixed length. It's created using an algorithm and is essential to blockchain management. Hashing requires processing the data from a block through a mathematical function, which results into a fixed length output. It basically acts like a fingerprint for the block. So there are 3 major components of blockchain. First and foremost is the fact that blockchain is typically a decentralized trust or distributed consensus, meaning there usually typically isn't a central entity. Secondly, it is immutability, meaning that data cannot be altered and remains unchanged. Each block of information, such as facts or transaction details, proceed using a cryptographic principle or hash value, which is what we talked about earlier. Lastly, it is auditability, meaning decentralized blockchains can allow any node to verify the authenticity of the chain.
Why use blockchains in wireless communications? Blockchain technology should be included in the improvement of wireless networks because it can be used as a mechanism for anonymous access control, change how networks tackle congestion avoidance with its proof of work technique, and enhance the IoT or Internet of Things landscape by establishing trust, interoperability, and a consensus mechanism at the broader level.
Let's start with access control. In wireless networks, access control is the processes and tools used to control the secured use of wireless local area networks, access points, and wireless client systems. We propose that blockchain can be used for access control in Wi-Fi networks. With blockchain, network providers can provide controlled access to authorized users. By adopting a virtual currency to accept payments, or by creating their own, they don't need to utilize and manage radius systems and protocols, resulting in cost reductions and not having to directly manage user data.
I'm going to be talking about blockchain and congestion avoidance. Using proof of work techniques as a requirement for users to gain the access to a wireless channel is an alternative to the current exponential backoff mechanism, which can improve fairness in the wireless access network in case malicious users violate congestion control procedures to achieve higher shares of wireless resources. As said before, the solution can be utilized to improve fairness of existing congestion avoidance schemes in wireless access networks such as Wi-Fi, and can be utilized to regulate access to the resources of a wireless access network in an anonymous way and without the necessity of deploying complex authentication infrastructures. The article by Alberto Brincat tests the solutions on a two-way handshake and using direct transmission.
By 2025, there is estimated to be nearly 21 billion IoT devices. These devices range from home security to healthcare devices and nearly everything in between. Because of this, as well as their accessibility and hardware constraints, security and reliability are a top priority. Current IoT ecosystems are centralized. A central cloud server is necessary for the identification, authorization, and communication between devices. This results in large server maintenance costs, as well as resulting in a single point of failure. So how can blockchains be implemented into IoT ecosystems? Most IoT devices are limited in power as well as computation ability. These are two things necessary for blockchains to function properly. Because of this, a divide and conquer method is proposed. Rather than each individual node of a network all performing the necessary functions of the blockchain, the tasks are split between three different types of nodes. Minor nodes, which create and verify new blocks. Full nodes, which download every block, verify every transaction, and maintain an accurate state database of the blockchain network. And light nodes, that only perform enough tasks to create and verify the validity of transactions that apply to that specific node. The image shows these nodes working together in an IoT setting. Why even use blockchains with IoT devices in the first place? Blockchains enable cost-effective and safe transactions. This is a key feature missing from current IoT ecosystems. They also allow for the secure and reliable communications between two smart devices without the need for a centralized authority. This removes the single point of failure discussed earlier.
Now I'm going to be talking about some of the weaknesses and exploits found in current blockchain solutions. Let's talk a little about scalability. The more people or nodes join a certain blockchain network, the chances of transactions in that network being slowed down increase. Another issue is data being immutable, meaning that data cannot be changed. Since data put in a blockchain cannot be removed or changed, possible issues related to the right to privacy may come up as more blockchain solutions are implemented into day-to-day activities. For example, if you have a social media that uses blockchains to store user data and posts, once that information is there, it's going to be very hard for that user to remove that, if not impossible. Talking a little bit about some of the possible inefficiencies, but also related to scalability. Because of the way blockchains operate, as the size of the blockchain grows currently, the more transaction and the more nodes operating in the system, the whole network may become a lot slower. Obviously, this is not ideal for huge commercial blockchains where it is essential for the network to be fast and secure at all times. If you were to compare it to the current Visa, for example, they can handle like 150 million of them a day, while blockchain is still working on that. Another, of course, money is always an issue. So cost of a blockchain solution is currently very high. So implementing blockchain solutions currently comes with high costs related to hiring developers, training the staff to excel with aspects of blockchain technology, the licensing costs, and of course maintenance and others. Some of the discussed solutions are for scalability is also to hold the actual transactions off the blockchain and save the blockchain solution to only store in order to only store and access the information. And this is a possible way that they have found to alleviate the stress in a blockchain network with a lot of nodes.
In terms of our personal assessment, blockchains are the bee's knees. Just like how companies outside the financial sector plan on using blockchain to disrupt industries such as healthcare, supply chain, and more, we believe blockchain technology has the capability to do the same in wireless networks. We believe this technology has the capability to change wireless networks as we know it, but possibly even start a breakthrough for actual decentralized networks and systems. Now, let's head into our Q&A.
So here are our questions for the presentation. In what other ways do you see the application of blockchain solutions in wireless networks becoming more prevalent in the future? What lacking security aspects of IoT devices are believed to be solved with blockchain technology? How so? Do you think decentralized wireless networks will become more common as blockchain solutions get adopted over time? How do you see cryptocurrency and other digital assets be applied in wireless networks? Could a tipping system exist maybe?